Hey all, today we're going to continue our discussion on collecting data. We've already talked about running simulations, and now we're going to talk about random sampling. And so the first part we need to discuss is knowing who we're gathering information from. And so we have talked about this before, that a population is the entire group that we want to know something about. Populations are typically large, and they're typically not possible to get in touch with everybody in a population. Even if you think about our school, if the students population we're interested in, it would be very hard to get in touch with all the students at any time, because at any given time there are students missing from the school for various reasons. And so getting in touch with populations is really difficult. But if we did know something about the population, those things we would call parameters. So for example, if we're talking about a mean, we would use the letter mu. So the population mean is represented by that value, mu. Population standard deviation is sigma, so on and so forth. And those things would be called parameters. But typically what we have are samples, smaller groups that we want to be representative. It's important that our sample is representative of our population. The way that we get a representative sample is by using random methods. Anything we find out from a sample, we call a statistic. So population parameter, sample statistic. For example, a sample mean, X bar, a sample standard deviation, S, so on and so forth. So it's really important to know, who are we finding out about, and what group are we finding that information from? So what is our population, and what sample are we going to use? And so a way that we can get information from a group of people is to survey them, ask them questions. And survey design is something that we could really go in depth with, but we won't. We will just talk about sort of the basics and how to sample. If we were to get a survey from an entire population, that's what we call a census. The United States tries to do that every once in a while, and they still probably can't get everyone that they're looking for various reasons. But they get the vast majority, and so we can consider it a census. But what we'll probably focus on are sample surveys, and that is where we get a representative subset of the population. Again, we want our smaller group to be representative of our larger group, the population. And this lesson today is going to be a bit heavy on the vocabulary, so make sure that you are pausing, taking your time. You can rewind to make sure you get everything you need. And also this document will be available on Canvas. So as I said now a couple times, samples should be random. Random samples help us get representative samples of our population. They protect against bias. And when a sample is truly random, any individual in the population is given a fair chance to be selected. And again, there I'm just really highlighting the fact that our samples need to be representative of the population. So a bad sample of students in our building, if we wanted to find out something about all of our students in our building, it would be a bad idea to just ask the seniors. They would have some sort of characteristic, perhaps their age, the amount of time they've been in school, the amount of time they have left in school, something in common that would bias them compared to freshmen, sophomore, juniors. So when getting a sample, we want it to represent our entire population that we're interested in. We always want to consider sample size. Sample size should be big enough that it gives us interesting information, but it doesn't need to be too big. So this is an example I stole from the book, but I really like. When you're making soup, if I were to make soup for the whole school, let's say, we have a huge pot of soup. If I wanted to know if that soup was good or if it needed more seasoning, I would stir that soup up, and then I would just use a regular spoon to taste it. I wouldn't have to use this whole ladle. I wouldn't have to drink a whole ladle of soup or drink a whole bowl of soup or eat a whole bowl. We can talk about which is more correct. I wouldn't have to have a whole ladle or a whole bowl of soup to know if that soup tasted good. A spoonful would be enough. I stir it up to make sure I mix all the ingredients. That's random sampling. and then I get a random sample of my spoonful of soup. So we want our sample size to be big enough, so that we can taste it, but it doesn't need to be too big because then it becomes unnecessary. So I like this soup example when it comes to trying to think about how big our sample needs to be. And as we go on through the year, we will talk about appropriate sample sizes to be able to draw conclusions. And so the final thing we'll talk about today is the sampling methods. And in the next lesson, we'll talk about mistakes or errors or bad sampling methods we could choose. But for now, let's talk about the methods in which we can obtain a random sample. So the first one is just called a simple random sample, often referred to as an SRS. So if you ever see SRS, we're just talking about a simple random sample. And that's where every member of the population gets a number, and then we randomly generate a decided upon number of individuals from that population, and that's how we generate our sample. So if we're thinking about school, everybody in school has a number assigned to them, their student number. And so we could generate, if we wanted to get a random sample, let's say of 50 students from this school, we could randomly generate 50 unique numbers. We would want them to be unique numbers. We wouldn't want to sample somebody more than once. 50 unique numbers, and then we could go talk to those 50 students, and hopefully we would have a representative sample of our school. A stratified random sample, we're going to do some simple random sampling, but we're going to do something first. We're going to break them up into groups. And those groups have a name called strata for stratified. And we're going to break them up in a way such that each group has a characteristic in common. So the best example for school would be we can break you up into graduation year. Which typically would be freshmen, sophomores, juniors, and seniors. I know there's some variation there depending on how long you stay in school, but we can break that into freshmen, sophomore, juniors, and seniors. And so they have something in common, their age. And so what we would do is in each strata, we would take a simple random sample. So if we wanted to make sure that when we were doing our sample, we had every grade level represented, because that was important to us, then we would break them up into groups by graduation year, and then in each group we would take a simple random sample. So we are sampling some from every group. A cluster sample is similar, and I'll tell you right now that these are the two people get most confused. We're going to break those into groups. We call those clusters. So for example, we have clusters that are naturally formed in school. We could, let's say our clusters are first periods or first block. And so if we were going to do a cluster sample in the school, we have defined clusters. Everybody goes to their first block. And then what we would do is we would randomly sample. So we would do a simple random sample of clusters. So we would, let's say, randomly generate room numbers. And we would maybe want to sample 10 first block classrooms. So we would generate a simple random sample of room numbers, and then we would survey everyone in those clusters. So the difference here is in the stratified random sample, we are taking a sample from each group. In cluster sampling, we are sampling a group of, or a small amount of the groups, and then in each of those groups we sample everyone. If I got a little tongue-tied there and you need me to re-explain, please do ask me. These two are the ones that people get most confused because they're most similar. We're grouping. Stratified, we sample every group. Clusters, we sample some groups, but we sample everyone in those groups. A systematic sample is one where we assign everyone numbers. So everyone gets a number. And then what we would want to do is randomly generate a starting point. So if we are back to our student numbers, we could randomly generate one student number, and then we would decide upon a number of numbers to go by, and then we would pick we call it every nth. Because the amount is up for choice. So let's say we randomly generate one student number and we sample that person, and then we sample every person that's 10 numbers higher. So we go to the 10th person in line after that, and then the 10th person in line after that, and then the 10th and the 10th until we build our sample. I think I originally said 50, so until we get 50 students. And then I know almost all of these have some second layer to them. So stratified and cluster, we group, and then we take a simple random sample. In a systematic, we do generate a random number and then do a systematic sample. But multi-stage would be some combination of these methods. I feel like I spelled that wrong. Somebody will tell me. So if you're paying attention, you'll know whether or not I spelled that wrong. I'm looking at it and it looks like it's wrong. So you all can correct me if I'm wrong and then tell Mrs. Pickard. So multi-stage, stratified cluster would not be considered multi-stage, but perhaps perhaps I stratified and then within my strata I did clusters, and so that would give me an extra layer, and that would be considered a multi-stage sample. So please do, if my bad spelling or maybe a tongue tie or my examples did confuse you, or you just need a little clarification, please do ask for help. Make sure you answer the questions at the end of this lesson. Take your time on those, and good luck.